Students, let us solve this Irodov problem number 1.85. A small sphere of mass m suspended by a thread is first taken aside so that the thread forms the right angle with the vertical. What is the question? There is a small sphere of mass m connected by a thread. Initially, the thread forms right angle with the vertical. Right angle with the vertical means thread is horizontal. So this is the initial situation of thread. Thread is horizontal and a sphere of mass m is connected with this and then released. Released means u equal to 0. At t equal to 0, u equal to 0. Now, in this question, length of thread is not given, so I assume the thread length is L. So, the thread length is L, so this length is also L. So, after releasing, this sphere perform a circular motion of radius L. Okay. Now, we have to find the total acceleration of the sphere and the thread tension as a function of theta, the angle of deflection of the thread from the vertical. So what is the question? At any time t, when this sphere go down, so this is the position of a sphere at time t, it form angle theta with vertical. The angle between thread and vertical is theta. So at this situation, I have to calculate first total acceleration, second the tension in this thread. Okay. Now how to do that? So if I release this sphere and when this sphere go down at this position, there should be a velocity of this sphere. So let me first calculate the speed of a sphere at this point. For that, I use the work energy theorem. How I can do that? Let me first find the height of a sphere fallen down. So this is a right angle triangle. This angle is theta. So this angle should also be theta. This length is L. So this length is L cos theta. So a sphere go down L cos theta height down. So the velocity of this sphere at this point is, we have formula V should be equal to under root 2gh. So V should be equal to under root 2 into g into h is L cos theta. So the first important data is the speed of a sphere, which is equal to under root 2g L cos theta. Okay. Now, the sphere is performing a circular motion. So the total acceleration of a sphere have two components. One component along the center, which is called AC, and one a tangential component, which is called AT. So I already know the formula of AC. The formula of AC is V square divided by R. So a square of V, which is 2g L cos theta, and radius is the length of thread, which is L. So AC equal to 2g cos theta. Okay. So the second important point is AC should be equal to 2g L cos theta. Now to calculate the AT and total acceleration, let me draw the free body diagram of a sphere at this point. So this is the radial line and this is the tangential line. Now mg will act in downward direction and tension in thread will act along the thread. So this is the tension T. If this angle is theta, this angle should also be theta. Let me break the component of this mg. The component of this mg along this line is mg cos theta, and component of mg along tangent is mg sin theta. This is mg sin theta. So I don't need this vector because I break the component of this vector. So these are the forces acting on the sphere. The AC part is along this direction. So this is AC, and AT part is along this direction. So this is AT. Now write the Newton's law equation, one along AC and one along AT. So along AC the equation is T minus mg cos theta should be equal to m into AC, and along AT line is mg sin theta should be equal to m into AT. So m and m cancel out. So AT should be equal to g sin theta. So the third important result is AT should be equal to g, not L. L is no. AC should be 2g cos theta. L was cancel out. So AC is 2g cos theta and AT is g sin theta. Correct it. AC is 2g cos theta, not 2gl cos theta. Okay. Now we have to find tension. So I can write T should be equal to mg cos theta plus MAC. I already calculated the value of AC. So T should be equal to mg cos theta plus 2mg cos theta. So the tension should be equal to 3mg cos theta. So the next important result is 4 number. T should be equal to 3mg cos theta. Okay. We have to calculate the total acceleration. The magnitude of total acceleration should be equal to under root AT square plus AC square. So it should be equal to, what is AT? AT is g sin theta. So a square of g and a square of sin square theta plus AC square. This is AC. So it should be equal to 4g square cos square theta. G should be common out. So 1 sin square theta plus cos square theta becomes 1. So it should be equal to under root 1 plus 3 cos square theta into g. So the magnitude of total acceleration is this. So the answer of first part, total acceleration, this is the answer of total acceleration, and the tension, this is the answer of tension. T should be equal to 3 mg cos theta. Now the question contains 2 more parts and we have to solve all the parts. So let me go to another page and see what is the next part. Part B, the thread tension at the moment when the vertical component of the sphere velocity is maximum. Okay. Vertical component of a sphere velocity, and it should be maximum. So at that theta, we have to calculate the tension. So first we have to calculate the vertical component of velocity. Then we have to find the theta when this vertical component is maximum. Then we have to calculate the tension at that theta. Okay. Now this is a part of circle and this is the velocity v. Magnitude I already calculated. Now I can break the component of this vector. So if I draw this vertical line and find this angle, this is the horizontal line. So if this angle is theta, this is 90 degrees. So this angle is 90 degree minus theta. If this angle is 90 minus theta, so this angle is theta. So component of this V along horizontal is V cos theta, and component of this velocity along vertical is V sin theta. So in question, the vertical component is asked. So I write the vertical component of velocity have magnitude V sin theta. What is the magnitude of V? It is under root 2gl cos theta. So it should be equal to under root 2gl cos theta into sin theta. Sin theta is out of the square root. Now, so one step is we have to calculate the equation of Vy in terms of theta. Now, we have to find the theta when Vy is maximum. We know the step that for that we have to differentiate this equation. But this equation is not a beautiful equation. So first I transform this equation. How? Square the whole equation. So Vy square should be equal to 2gl cos theta into sine square theta. So Vy square should be equal to 2gl cos theta into 1 minus cos square theta. So it should be equal to 2gl into cos theta minus cos cube theta. Okay, now I have to differentiate this equation. So differentiation of this part is 2Vy into dVy by d theta. It should be equal to, this is a constant term, so 2gl. The differentiation of cos theta is minus sin theta, minus differentiation of cos cube theta is 2 cos square theta, and differentiation of cos theta is minus sin theta, so 1 minus and 1 minus becomes plus, and cos theta becomes sin theta. Now for maximum value, this part should be equal to 0. It happen only when this part should be equal to 0. It means that sin theta should be equal to 2 cos square theta into sin theta. No, this is not 2, this is 3. One more mistake, this is 3. So this is 3. Sin theta should be cancelled out, and cos theta should be equal to 1 by root 3. So this is the angle at which vertical component of velocity is maximum. We have to calculate the tension in thread at this theta. So we already know the equation of tension, which is 3 mg cos theta. So tension at the new theta should be equal to 3 mg into cos theta, which is equal to 1 by root 3. So 1 by root 3. So T should be equal to root 3 mg. So the new theta, so the tension at new theta is T should be equal to root 3 mg. So this is the answer of part B. Now, in part C, the angle theta between the thread and the vertical at the moment when the total acceleration vector of the sphere is directed horizontally. So in part C, we have to deal with total acceleration direction. Now, I know the direction of tangential acceleration and direction of AC. But in question, it is said that the total acceleration should be horizontal. So if this is the sphere, the total acceleration is horizontal. So this is the total acceleration. This is horizontal, means this angle is 90 degree, this angle is theta. So this angle should be equal to 90 degree minus theta. Okay. Now I can break the two component of this acceleration. So one component which is so I draw this parallelogram. So the AT should be this. This is AT and this is AC. This is AC and this is the total acceleration A. Okay. Now, if this angle is theta, this angle is 90 minus theta and these two are perpendicular to each other. So this angle is theta and this length is AC. So I write that tan theta should be equal to AC by AT. So when the total acceleration is horizontal, it means that tan theta should be equal to AC by AT. Now I already calculated these two terms. AC should be 2g cos theta. So it should be 2g cos theta and AT should be g sin theta. G sin theta. So tan theta should be equal to 2 divided by tan theta. So tan square theta should be equal to 2. So tan theta should be equal to root 2. So the answer of part C is this. The answer of part B is this. And we already calculated the answer of part A. So these are the three basic terms and basic velocity, acceleration, tension part which is asked in this question. This question is a very good question. In one question, it covered major concept of the circular motion.